I'm very interested in old and obsolete technologies. Firstly, because by studying them we can gain a better understanding of modern technologies, but also because by revisiting them sometimes we find they aren't as obsolete as we think. When a technology becomes obsolete, it's sometimes because of a combination of factors. A good example of this is the old landline phones. Given the phone service was never intended to be used to transmit data, it's impressive that the engineers of the day were able to squeeze that level of performance out of simply sending audio signals over the lines. But we needed more bandwidth, and other technologies were better able to provide it. And the high cost of long-distance calls could make internet and phone service expensive, so landline phones slowly lost prominence. Then smartphones put the final nail in the coffin of landline phone service. But now that computers and the software that runs on them have had 20 years to improve, is it possible to take better advantage of the bandwidth available on these old phone lines? What sort of voice quality are they really capable of? Some of us remember trying to do voice chat with these modems back in the day. Have things improved? To test this, I have two 56K modems connected together into this patch panel. The patch panel simply acts as a crossover cable so the two modems can talk to each other. Then I have a power supply connected to the panel to energize the circuit when the modems go off hook. There's no dial tone or ring voltage being supplied here, so we'll need to disable all of that in the modems when we set them up. Most of us are used to using these modems to dial into an ISP, but we're not doing that here. This is more like a fax machine. One modem is dialing directly into the other, then they start sending data directly to each other. So we only need to worry about the quality of the phone connection. In theory, this should be more reliable than a voice over IP phone that operates over the internet. Both modems are connected to my Raspberry Pi 3B+, which you may remember from my past videos. I've put some additional software on the Pi so I'm able to use the modems. The modems will be configured to run at 33.6 kilobits per second. Although the maximum download speed these modems supported was 56K, upstream is limited to 33.6, so they're only able to talk to each other at that speed. Now we'll switch over to the Pi and get the modems configured and talking to each other. I'm going to just reset the modems and load the configuration I want them to use by entering these AT commands. These commands are how all phone modems were configured, and even today the cellular chips used in modern smartphones use many of these same commands. Among other things, I'm disabling the check for a dial tone and setting the baud rate that I want them to use. Now for the last command, I need to tell one modem to dial and the other modem to answer. Since the modems are directly connected together, they aren't actually dialing anything, just going off hook and establishing communication. If these modems had speakers, this is where you'd hear the classic modem noises, but unfortunately they don't, so you'll just have to use your imagination. Now they're connected at 33.6 kilobits per second, and if I type into one terminal, I can see it appear on the other. So now we know everything works. Now the fun begins. For this test, I'm using the Opus codec. Opus is an open source codec that's designed to work well for both voice and music. I'm running it at 29 kilobits per second with an audio sample rate of 48 kilohertz, so this is full band audio. Since ultimately this is intended for use in phone applications, the sound is mono. So now you're hearing me through the phone line. The sound quality is excellent, and I can't really tell a difference from uncompressed audio. I would argue this is broadcast quality, at least for voice. I'll also demonstrate music. Of course, it's not stereo, so there is a drop in quality there, but it's still much higher quality than I expected from such low bit rates. I'm going to drop out here for a second while I play.
It's all about humanity. About humanity. It's all about humanity.
I think you get the idea from that. There's a huge delay between when I actually do something on the computer and the voice travels through the system, which is why you see things on the screen happening long before you hear my voice. But anyways, back when these modems were cutting edge tech, I had a portable MP3 player with 32 megs of storage, and I used to encode songs at 32 kilobits to put on that, and they sound like absolute garbage compared to this. So a fun result or experiment and a good result. And I'm comfortable saying that analog modems aren't quite as obsolete as I previously thought. But is any of this practical? Maybe in highly specialized use cases. If you need a reliable way to transmit broadcast quality voice and all you have is a phone line, I could see this being useful. Art Bell, for example, used to use an ISDN line to transmit his show from his home studio to his broadcaster. Perhaps this could be a reasonable alternative. Perhaps as a way to connect radio repeaters in remote areas. Or when you need a bit more reliability than using VoIP over the public internet. Who knows? You tell me.